Hello all the crazy people out there, my name is Michael, I like wizards and dragons and making games, and I am back for yet another video about blurs and shaders in GameMaker. So I've made a few videos on blurs and shaders in the past. I made a while ago, I made a video on 1-pass Gaussian blur, which looks okay, but it doesn't perform great. A little more recently, I made a video on a 2-pass Gaussian blur, which is quite a bit more efficient. The performance cost only scales linearly with the blur size, rather than polynomial time the way that 1-pass Gaussian blur does. And today I'm going to talk about another method of doing blurs, which is a radial blur. So the blur videos that I've done in the past will essentially boil down to taking the average of all of the neighboring pixels in a given region. And on some level, that's the basics of how pretty much all blurs are going to work. Again, doing the blur in 2 passes, a horizontal pass and a vertical pass, is quite a bit more efficient than doing it in 1 pass for reasons which I explained in that 2-pass blur video. But there are other approaches to doing blurs and shaders, and maybe you think that having to apply a blur in 2 separate draw passes is kind of a pain, and maybe you'd prefer to do instead some kind of radial blur. Anyway, just because I like doing this is the picture of my rabbit, which I've been using for a lot of these blur videos. This is what happens when we increase the blurriness value, the blur radius, you could say. So I'm going to start with the GameMaker project that was the 2-pass blur video. I'm going to, just because I think it might be nice to have all these blur shaders in like one project or something like that, I'm going to create myself a new shader. I'm going to call that SHD Blur Radial. The vertex shader can stay as it is, we don't really care about that. And the uniforms that are getting passed into the shader, the texture size and the blur radius, those are actually fine. We can keep those. We're going to need to pass those into the shader for setup purposes, for pretty much the same reasons that we needed them in the other blur shader. It's just this stuff in the middle that we're going to be messing with over the course of this video. So let me get rid of some of this extra like surface ping pong nonsense from this draw event here. So instead of drawing the image onto a surface with the horizontal blur and then drawing the surface onto the application surface with the vertical blur, as I said, the radial blur is just going to work in 1 pass. We're not going to have to bother ping-ponging surfaces around. Should be somewhat nicer. And now I'm probably going to spend the rest of this video in the fragment shader of the radial blur. So a quick bit of theory. The horizontal and the vertical blurs that I was doing before worked because we would just look out, we would iterate over a certain number of pixels above, below, left, and right of the pixel that we're actually drawing. We would effectively take the average of all the colors of those pixels, and then that would be our final output color. A radial blur, you can probably guess how this is going to work just based on the name alone. A radial blur is, instead of going horizontally and vertically, we're going to loop around the pixel that we're rendering. We're going to kind of sample points in a spiral around it. I'm going to start off by doing this in a fairly straightforward way, and the results are going to be something that you could probably identify as blurry, but they're not going to be great. And then once I'm done with that, I'm going to make it a little bit more complicated, and it will hopefully produce a much nicer blurry result. So first, I'm just going to for now, I'm going to hard code in. We're going to take 32 samples from the from around the pixel we're trying to render. I'll probably set that to a uniform later on in the video. But if I wanted to simply go around the pixel that we're drawing, around the fragment that we're drawing, in a loop, with 32 samples, and say that each of those samples is going to be evenly spaced, I could start with a for loop that goes from I equals 0 to I is less than 2 pi, because angles and shaders and computers in general work in radians rather than degrees.
Hey.
I plus equals 6.28 divided by samples. The texture coordinates. Well, firstly, the texture coordinate of the fragment that we're actually rendering is going to be the varying from the vertex shader, as I'm sure you all are well aware. And if we were to go in a loop around that point, we could say vec2 sample chords is going to equal v_v text chord plus a vector 2 of, let's say, cosine of the angle and the negative sign of the angle, or the positive sign, it doesn't matter. We're going to go loop around the pixel in either case. And this is going to be our new texture coordinate. However, I am going to need to multiply that by the texel size, which is 1 over the texture size, because texture coordinates. And each of these points is going to be a distance of like 1 texel away from, 1 pixel away from the fragment that we're actually drawing. So you might want to incorporate the blur radius in there as well, like that. Next, let's say total color, which is our accumulator value from the previous blur shaders. This can plus equals texture 2D gm_base texture, and the texture coordinates can be the sample coordinates. And then when we are all finished, total color divided by equals the number of samples, because that is the number of things that went into that accumulation value, and we can hopefully call that a day. So again, this isn't going to produce a great result, but it should set us on the way to doing something that looks recognizably like a blur, and we're not drawing anything. Did I set this up wrong? This does work if I just like... Oh, I'm not actually drawing anything, am I? Alright, so I need to actually like draw something if I want that thing to actually be like showing up on the screen, so it's a little important. Alright, so if I increase the blurriness value, we can get something that looks, again, somewhat recognizable as a blur. If you want the blur in your game to have an effect like you got hit over the head and you're seeing stars or something, this might be acceptable, but we can do better. We can definitely do better than this. So what if instead of just doing a straight loop around the pixel that we're drawing, with an increasing radius based on the blur radius, which, again, causes us to see something like our eyes are maybe a little out of focus, or like we got hit over the head with the rock or something. What if we started out this radial blur with a small radius and increased it with each pass around the each coordinate that we sampled? So we're going to sort of, instead of sampling from pixels in a ring around the main pixel, we're going to more like sample pixels in a spiral around it. I really need to make up my mind if I'm going to call them texels or pixels or fragments in this video. Like, technically they're not all the same, but when normal people speak about such things, they're pretty much all the same. Anyway, so you can play around with numbers in quite a few different ways to create a spiral as you like ascend the like as you go around the circle. I'm going to kind of cheat and use the solution that XOR, the GameMaker shader god, uses in his radial blur. Anyway, what XOR does, and what I rather like, is that we can weight the radius of each sample that we're taking, so that most of the samples are a little bit closer to the to the actual texture coordinates, and that only a few of them are farther away. So to do that, I'm going to not declare a variable with var because that's GML, but we can say float, let's say scale, is going to equal to the blur radius uniform, and we can divide that by the square root of the number of samples. And instead of multiplying the sample coordinates by like the texel size by the blur radius, let me multiply the sample coordinates by the texel radius by that scale value instead. And because we want our radius to increase a little bit with every sample we take, I'm going to define a float current radius. I'm going to initialize this to 1. And I'll get a little bit more to that, to why it's 1 and not 0 in a minute. For each iteration of the loop, we can increase current radius by 1 over the current radius. And in addition to multiplying the sample coordinates by the textile size by the scale value up there, we can multiply this by the current radius minus 1.0. And the minus 1.0 is not immediately obvious why we're going to be doing it here. If you initialize it to 0 and then try to say current radius plus equals 1 divided by 0, that's going to be, this value is going to be infinite, and then you're not going to really be sampling anything of interest. So because we want to let's say bias our sampler radiuses towards the towards the extent of the blur radius. So if our blur radius is 10, current radius will essentially become a geometric sequence. The current radius value will increase. It'll approach a value which I want to say is 1 plus the square root of the blur radius, something to that effect. You can add it up by hand if you want. 1 plus 1 over 1, and then you add another 1 over whatever the current value is, and so on and so forth. And then subtract 1 so that current radius only approaches a value of the square root of the blur radius. And then multiply by the scale so that you divide out that square root, and then your final radius is just the blur radius. Anyway, did I do everything that I want to? Did I make all the changes I want to change on this go around? I think I did. There are still more things that I'll be changing later on. You don't like that. Why don't you like that? Oh, this needs to be 1.0. I don't know why it's blaming line 19 instead of line 17, aside from the shader compiler being weird like that, but anyway. Yeah, 1.0 divided by current radius. We can increase the blur value, and we now have a little bit less of that. I mean, it's still there, but it's not quite as sharp as it was before, of that effect that we got, hit over the head with something. And you'll notice that the frame rate is quite a bit better than it was with the 2-pass blur, because unlike with the 2-pass blur, we're just increasing our radius here. We're just increasing our blur radius, but we're not actually taking more samples with a greater blur value. The sample count is at least currently staying constant at 32. Anyway, let's see. So there's a couple of other changes that we can make to this 2-pass blur shader, and I guess I can start committing changes. Because I like to encourage good habits sometimes. So right now, each of these samples has the exact same weight as all the others, and you might consider that it might make sense for samples that are taken farther away from the source pixel to carry less weight than samples that are taken really close to the source pixel, and we can do that as well. I'm going to define another float underneath total color. I'm going to say float total samples is going to be initialized to 0. And right now, all these samples have the same weight. We could effectively say total samples plus equals 1.0 as its weight, and then at the bottom, instead of dividing total color by the sample count, we can divide total color by total samples. That will produce the same result as we have now. But instead of that, what if we instead say float sample weight is equal to, how about 1.0 divided by the current radius, and then total samples plus equals that sample weight. And this way, samples that are taken closer to the source pixel will have a higher weight than samples taken farther away. Again, you can work this out by hand. So if current radius is 1, sample weight is 1.0 divided by 1.0, and then that sample has a weight of 1. If the current radius is something more like, say, 4, then the sample weight will be 1.0 divided by 4. Sample weight will be lower. So that's another change that we can make to make this a little bit better. Oh, good gravy. That is not normal. Alright, I'm also going to want to multiply I'm also going to want to multiply the sample color itself by that sample weight when we add it to total color. That definitely produced an effect. I'll say that much. So now If I increase this to, like, what was it before? 50? I've been using 50 as my stopping point. Alright, I think we can definitely say that that's another incremental improvement. Nice. Another change we can make is, instead of just taking each of the points in, like, 360 degrees around the fragment and, like, distributing them evenly and like going in a complete loop exactly once around the fragment, what if we were just a little bit more random than that? And, like, up until this point, I've done rotations, like, I've done rotations around a circle by doing cosines and sines in a texture coordinate, like sine of the angle, cosine of the angle, whatever, because that's probably what most people are familiar with. But I think now would be a good time to mention that you can also, there's an arguably easier way to do rotations in math, and that would be to take, for example, your vector 2 and multiply that by a 2x2 matrix, basically a rotation matrix. You're probably familiar with rotation matrices in 3 dimensions. You can also do them in 2 dimensions. And if you multiply a vector 2 by a rotation matrix, you will get another vector 2 which is rotated around the origin by whatever the angle defined in the rotation matrix was. And I'm just going to do that right now because I think that'll be a little bit more elegant than writing it out the long way. And hopefully you'll see what I mean in a minute. Firstly, I'm just going to write out a little bit of code and then I'll explain it when I'm done. Let's define a vector 2. I can call this rotated point, or let's call it rotated coord because I'm using that for everything else. This can be initialized to a vector 2 of 1.0 and 0.0. I'm going to define a 2x2 matrix. I'm going to call this the let's call it rotation angle, and this can be a matrix 2, mat2. And this is going to contain a few magic numbers, which I may or may not have stolen from XOR's radial blur code. This happens to be a rotation matrix representing a golden angle rotation. There's a bit of mathematical theory behind why XOR and others might choose the golden angle for a rotation matrix like this. First and foremost, it has been called the most irrational of irrational numbers, which means in normal person speak that if you continuously rotate around a point by the golden angle, you will be least likely to notice a pattern if you use the golden angle phi, as opposed to using some other irrational number or constant of nature. You could pick another angle to rotate by, I don't care, but I'm just going to go with this one. Next, inside each iteration of the for loop, I'm going to say the rotated coordinates multiplies by equal, so times equal the rotated angle. And now the rotated coordinates is equivalent to the value that I just replaced here, so the vector 2 containing the cosine and the sine. It is slightly less code. It is also slightly more efficient because you're not computing trigonometry functions in every iteration of the loop. You're just doing a little bit of simple matrix multiplications. Currently this rotated coordinates vector 2 has a magnitude of 1. It's just being rotated around the origin point. If you want to make this a little tiny bit more elegant and optimized, you can also, instead of giving it a magnitude of 1, you could just encode the scale value inside that vector and not have to do the multiplication here. Everything else should stay the same. I think that's all I want to do for this change. And now if I run the game, we're actually not done yet, because I also want to let's see, the iterator I isn't used here for anything anymore. Like, we're not treating it like an angle or anything, but I kind of would like to just say I is less than samples I plus equals 1.0. Because that's it's easier to read. Anyway, now if I increase the blurriness, what was it, 50? We can definitely see it looks more blurry than it did before, we've still got a little bit of weirdness. Now it looks less like we got conked over the head with a coconut or something, and more like we're looking at the image through like frosted glass or something like that, which again could be an effect that maybe you want. But if we want to go for an actual blur, I think there is one more change that I would like to make before we call it a day. And that is... Alright, yeah, there's one more change I want to make. Firstly, we can commit that. And secondly, we're going to introduce a little bit of just random noise into the equation here. So, I recently made a video on randomness and shaders. I would recommend going back and watching that if you haven't. I'm just going to not spend a ton of time discussing how randomness and how hash functions in shaders work. I'm just going to copy and paste this for my test project. I don't believe these are the same like random coefficients that I was using in that one video. I think these are values that I got from XOR's code in a sort of like if it ain't broke, don't fix it sort of way. But any random coefficients should work, I think. And I'm also going to not only return a vector 2 here for a 2D noise function, but it's also going to be normalized. And it's going to have a, this random vector 2 here is going to be normalized, so it has a unit length of 1. And it's also, rather than containing two numbers between 0 and 1, it's going to contain two numbers between -1 and +1, and it is then going to be normalized. So, as always, to like change the range of a set of values, you can subtract by 0.5 to put it in the range of -0.5 to +0.5, and then that vector 2, you can use the normalize function on that, and that will make sure that it has a unit length of 1. So, to actually use this, let's see. I'm going to say the rotated chords can be a random value based on let's say v_v texture coordinates. This will return a vector 2. It will have a magnitude of 1. We would like this to have a magnitude of the scale value, so I'm going to have to multiply by that. After we're done there, and I think that's all of the changes I really need to make to this code to introduce just a little bit of random noise to each of the fragments that we're blurring here. So, all right, we can definitely see it looks blurry. If I increase the blurriness up to 50 here. The picture of the bunny is indeed very blurry. Now, this is a little bit different of a blurry effect than the two-pass Gaston blur will produce. So, you can see here that visually it looks a little bit grainy, like we've superimposed sandpaper or something onto the image that we're blurring or something like that. I'm not entirely sure of what the best way to reduce that effect would be. This is, again, you could make the argument that this is an artistic effect. I know that, there's a bunch of Photoshop filters for, frosted blurry image filters that look something like this. So maybe if you want to go for something like that, you could say this is exactly what you're looking for. How's it going to look if I keep increasing the blur radius? It doesn't really change much after this point. Alright, the grainy effect is still there, and, alright, enough of that. You may notice that the actual frame rate does go down, the higher the blur radius is here. I'm actually not 100% sure why it's doing that. I suspect it might have something to do with, how the texture is accessed in memory. If you have a large blur radius with this radial blur, we're not actually doing more calculations, but we are sampling from pieces of the texture that are, not anywhere near each other. And I wonder if it's possible that, at least on, my fairly old GTX 1060, if this has some effect on, how the texture is stored in memory or in cache or something like that.
Hey.
Anyway, that's a radial blur. Oh, I did say I would do one more thing. First, let's see what happens if we set a sample count of something lower, like 10. this will definitely produce a lower quality lower quality blur. This is definitely, the grain is more apparent here when I set the sample count to 10. Although it's at a radius of 50, it's still not that bad. Whereas if I set this to something like, I don't know, 80, much higher sample count than we had before. I wonder if this will actually make the oh, this is taking such a long time to compile because I suspect that the shader compiler is trying to unroll this for loop, and 80 is just too many to really... Anyway. Alright, that definitely took care of the grain a little bit, but it is quite a bit more expensive because we are doing more texture fetches there. And also that, fine, I'll make this uniform. I need to get rid of it there. I need to get rid of it there. Looping over a uniform might also be slightly less efficient, but that's the kind of thing that I would recommend not worrying about. Let's see. Kernel size, sample count. What if I parameterize the sample count the same way that I'm parameterizing the like the blur radius here? How's that going to work for us? All right. So at a sample count of 16, it looks something like this. If I increase, decrease, whatever the sample count, you could definitely make the argument that we're improving the quality of the blur by increasing the sample count, and you can imagine why. More samples means more like data to pull from. Definitely getting grainier as I reduce that. Alright, that does not look blurry. That just looks like my screen is broken. Alright. I'll put these in the reverse order. So that is radial blurs. Definitely the way that it works a little bit differently from the way that a straight up Gaussian blur might work. You might prefer doing it this way. You might prefer doing it with the 2-pass Gaussian blur or the 2-pass box blur. I think a Gaussian blur would technically have to be like weighted, which this isn't. But anyway, whatever you want to call it. I'm going to end this off here. My name is Michael. I like Wizards and Dragons and making games. If you want the code for this, look for the GitHub repository down in the video description. I will also have a link to Xor's GitHub, which is where I got a lot of this logic from, down in the video description as well. If you don't know him, Xor, the GameMaker shader god, does all kinds of insane things with shaders. You might consider seeing what he's up to, throwing him a follow if you're interested in this sort of thing. I try to post about 2 game dev videos a week, one tutorial like this, and one Let's Make a Game, currently a 3D Zelda-like wizard game, so if you're interested in any of that, feel free to subscribe. I have a Patreon, so if you want to contribute to the channel, links to that can be found in all the usual places. You should all totally go wishlist Wizarducks, which is the game that I have been working on the side when I'm not doing YouTube stuff. I'll have a link to that down there as well. I hope you all found this useful, and I will see you all later. Special thanks to Zenjamin, VitroV, Squarecrow, Manta Ray, GameMaker, Edward Holt, and DJ Gibbles for supporting these videos. If you want to contribute to the channel, head on over to the Patreon page down in the video description to join the fun.